Let us look at what we mean by the domain and range of a relation, a very important topic which plays its full role in functions. Now, when we consider a relation from set A to set B, of course, we'd be looking at ordered pairs, and each ordered pair would be consisting of elements, that is A and B. The first element coming from set A, and of course, the second element coming from set B. So, in such a case, if we take all the first components or the elements coming from set A, we call it the domain, and naturally the elements belonging to set B, which forms the ordered pair, is what is called a range. That is the set of all first components or coordinates. Now, why are we adding this word coordinates? Because it can be graphically represented in a Cartesian plane. That's why the coordinates is added. So the set of all first components or ordered or coordinates of the ordered pairs belonging to a particular relation is called the domain of that relation. And naturally, the second component, so that is a set of all second components of coordinates of the ordered pairs belonging to a particular relation is what is called the range of a relation. And let us look at a very simple case. And it's written as DOM, and that's domain of a relation and range of a relation. And in a set builder form, it's represented as domain is A such that AB is an element of R. Of course, the A should be a part of that ordered pair to be considered as belonging to a domain, and naturally that's the case also with B. And not the important point that the domain would be a subset of A, which simply means that all the elements of, it's not necessary that all the elements of set A should be forming ordered pairs. And that's also the case with range, where the range is a subset of set B. And of course, range is written as B such that AB is an element of R. And also, an important part is that set B is called the codomain of the relation R. Now, let us take the case of very simple case of set A having elements 3, 6, and 9, and set B having elements 2, 4, and 3. And there are three ordered pairs are coming up in that particular relation, that is 3, 2, 6, 4, and 9, 3. And of course, you have 3, 6, and 9, which are which forms the elements of the domain, and 2, 4, and 3, which forms the elements of the range. Now here in this particular case, all the elements of A and B are present, but it isn't necessary that all the elements of the participating sets ought to form the ordered pairs, and that's an important point which we should know. And that's why the subset property was stated in the just stated before. Thank you.